Well, hey guys, it's good to see you. It's been a minute. I told myself in the start of 2025, I actually told myself to start of 2024, I'm going to do these videos a little more often. And then the storms rolled through just a couple of days ago, and I had folks reach out saying, "Hey, look, Nick, it would be really nice if you could do these videos a little more often." And so here I am, hopefully doing these videos a little more often. January 7th, 2025 forecast update for the areas that you see highlighted here. Probably most applicable for the darkest red, but generally applicable for areas outside of that as well, kind of as you move away from that darkest red. And by the way, if you are new here, hey, I got an app. You can download it, Android, Apple. I think you can put it on a Chromebook. Pretty sure you can put it on a Chromebook. I think you can put it on Apple TV as well. 10,000 active users. A big thank you to everybody who uses the app. You guys rock. So, what's up? Well, we got a cold couple of days headed our way. Then we got some precip that shows up kind of Thursday night and into Friday morning. And then that rain is going to probably stick around through the day Friday and perhaps even into Saturday. We may see some brief rain-snow mix, sleet-rain mix. It may actually come down as all snow for a little while, perhaps even all sleet for some folks as well. Travel and life impacts are possible, but not likely at this point for points south of I-20. Now, once you get north of I-20, that changes a little bit, but for south of I-20, that's probably the play right now. Current conditions across the United States, of course, we got plenty of cold air up in Canada. That cold streak that you see, by the way, here in the central United States actually has to do with snow cover more than random displaced, cold. It's not like a chunk of the air from Canada just sneak through parts of the Dakotas and plop down into Kansas and Missouri. It's because they've got a whole mess of snow and ice on the ground, and the ground can't absorb the heat, and so it reflects all of the sun's energy back into space, and you don't warm up. Not really a lot of precip on the map either for the United States. We do have a whole mess of wind for parts of Southern California, but kind of outside of that, not much doing. 43 degrees in Hattiesburg as of this recording, 40 in Meridian, 39 out in Tuscaloosa, 32 up in Greenville. Natchez hanging out at 34. So if you're in the valley of the Mississippi River, you're a little bit cooler than kind of other more elevated places. But I know that all you guys care about is what's going to happen on Friday. Well, pre-dawn Friday, this is kind of how things break down between the NAM model and the high-res NAM model. They're pretty similar, but we can kind of get in here and you can kind of see the difference between the low-res and high-res look. Low-res, high-res, low-res, high-res. It's like being at the optometrist, right? You like number one or number two? Number one or number two? Which one's clearer, number one or number two? Well, you'd say number two is clearer, but this is probably a good time to talk about what models are good at doing. Models are just tools, right? Just like you'd work on a car or do anything else, right? I mean, I got this flashlight sitting here, Christmas gift, and a tape measure. Good tools, probably not great for screwing in a light bulb. Right? You're not going to use either of these. They're useful for what they're useful for, right? If I wanted to measure how long this desk is, hey, this is great. I got my tape measure out. If I wanted to blind the camera, I could do that with the flashlight. But they're not good at, hammering in a nail. I mean, don't get me wrong. I've used a flashlight to hammer in a nail before, but it's not very good at it. And that's with some of these models. You see stuff all over social media all the time. This snow map, that snow map, this model, that model. Well, is that model good at modeling that thing? Is that the proper tool you should be using? Had somebody reach out to me today and say, hey, look at this map of ice and snow from the CMC model. Is this any good? Is this worthwhile? I had to tell them, no, it's kind of a worthless model for what your map is showing, right? It can do it. I can use this flashlight to hammer in a nail, but it's not very good at it. And these models are the same way. And there's tons of these models all over the place. And when wielded by people who don't fully understand what they're talking about, they can take advantage of you, the end user of some of these maps. If you're scrolling through Facebook or hanging out on TikTok or Instagram or wherever the heck you guys are hanging out, and you see somebody go on and be like, oh, this model map is showing 13 inches of snow for South Mississippi and Louisiana and Alabama. So, just got to be ready, just in case, guys. Well, that model may be just as good as this flashlight at pounding in a nail. You don't have to be prepared for that at all. You got to use the right tool. Anyway, I'll get off my soapbox. The NAM model tends to run a little too warm, a little too humid, which means it's got a little too much moisture. And you can see that's a lot of moisture on these maps, right? I mean, that's a lot of rain. But because it runs a little warm, you can kind of see that as you turn up the specificity, right? As you get a little more refined, you turn up the resolution. Notice how the snow moves farther north and the ice moves farther north, because as you increase precision with a model that runs too warm and too humid, you can remove some of the ice and snow from places that may actually have a chance at getting some snow and ice. So, we can kind of look at the skew T here and we see, okay, well, we got our warm nose in here. Okay, we're making snow. Here's your dendritic growth zone, 19,000 to 22,000 feet. We're right there. These little pink lines over here are a good indicator, easy for me to say, of forcing inside the clouds. So, right, so we're pushing more moisture in there than the clouds can hold, and so what we're probably doing is squeezing out some snow or rain or supercooled rain droplets, whatever we're doing. But we have some forcing in here. And so if we make a snowflake up here, it's going to travel along this red line, which is a temperature line. And that green line is the dew point line. All your temperatures, by the way, are down here on the bottom. This is a skew T. You read it skewed, kind of to the side, like this. And it does this because it's the skew T log P. You're taking logs. Don't worry about the math. Just know that you're looking at this thing kind of sideways. If it helps you to tilt your head to the side and look at it, you can do that too. You wouldn't be the first person to do that. So this thing shows us that we've got snow falling till about 10,000 feet, and then it's probably going to start melting because the temperature then moves above the 0 degrees Celsius line right here. Right there, we do everything in Celsius and weather because it's a little bit easier to do the math. Not that Fahrenheit isn't great, it's fantastic, go America, freedom units all the way, but it's just easier math. So it starts melting, and you can see how warm we get. We're like 5 degrees C at about, we'll call it 3,500 feet. So you're now approaching about 40 degrees, and that's really going to melt a whole mess of snowflakes. So we're probably, according to this model, not going to see snow in our area all the way down to the surface. Okay, well that's fine, but let's take a look at what the European model has to say about this. And this isn't a race of models, we're just using different tools to see which one may show something else. One isn't necessarily more accurate than the other, one is just more useful than the other. In this case, this doesn't show things quite as warm, right? I mean, like you can see the difference. See how that red and green line moves back to the left? Back to the left? Back to the left here? It's because it's showing a cooler, and in fact, this is kind of funny. So just as, I didn't plan for this, I promise. You're never gonna believe me. I didn't plan for this at all. But notice how it's cooler and drier than the NAM, which is historically too warm and too humid. That's really funny, actually. I'll take it. So in this case, we're building snow at basically the same area, right? We're still up here making snow. This doesn't show the same data. That's the only reason that you don't see these pink lines over here. But we're making snowflakes. It falls till about the same point, and then starts to melt. But because the temperature is much closer to the freezing point, you're probably not going to melt quite as many snowflakes because you're saturating the air with snow that is, something about, we'll call it 10 to 15 degrees below 0 Celsius, which is about 10 to 15, about 15 degrees Fahrenheit. You're saturating this part of the atmosphere with snow that's that cold, so that's probably not going to melt as fast. And even if it does, as you get closer to the surface, you're a little bit drier. And when you saturate air that's a little bit drier, you cool it down to this little blue line. It's called wet bulbing in the weather world. Don't just go with it. And you wet bulb things, and you can actually cool down. And if I zoomed in close enough, you would see that we get just above the surface all the way back to about 33 degrees. And yes, that is above freezing. But if you have enough snowflakes in there, you're probably not going to melt all of the snowflakes, so you may end up with a rain-snow mix, or maybe even all snow. Or in this case, maybe you melt them all and then refreeze them, and then you end up with a little bit of a sleet-rain mix, or even all sleet. How long is that going to last? Well, not very. So the picture on the left here is in the morning, picture on the right is into the afternoon. And by the time we get into the afternoon, all the models, even the European model here, showing that we're going to be well above the freezing mark in kind of the lower to mid levels of the atmosphere, somewhere around 3 to 10,000 feet, basically up around 40 to 45 degrees, maybe even pushing 50. So Very, very warm, too warm for snowflakes, so it's going to be regular old rain. By the time we get to the afternoon, and then it's just regular rain from there on out. So as you kind of look at the forecast over the next 15 days, notice how chilly it is across the area. We're talking about temperatures hanging out in the 40s for afternoon highs. Today we hit 43 degrees, that was the forecast. 46, 47, 45, 48, back into the 50s by the time we get to the 12th and 13th and 14th, and back into the 40s again for the 15th, 16th, and then back into the 50s. And I think we finally break out of this kind of like chillier pattern as we get toward probably the 17th, 18th, and 19th of January. So, you've got probably about another week and a half of this kind of chilly stuff. I think there's a chance that maybe on the 13th and 14th we get back toward about 60 degrees in some places, but generally chilly as we head through kind of the next couple of week and a half or so, a couple of days for sure, with that shot for some precip in there on Friday. So hopefully I get to do these videos a little more often, and hopefully you found this relatively useful. And I will say, just like when I was on TV, it took entirely too long, but I hope you enjoyed it. See you guys later.